Hello, so I have a couple things to show. There's the HUD, the heads-up display. There's the interpolation in the networking. And then after that, I will show you a cool tool to debug the rendering. It's pretty cool. And then, yeah, I'm not going to show any code today. All right, let's see the HUD. All right, so that's the new HUD. I'm in widescreen right now, but the HUD will adapt whatever you're widescreen or not. The things on the side will get closer and the part here will stretch. So it's all perfect. So I will explain what you're seeing there. So I'm not a fan of the color, like the green. I will tweak the color eventually. It's configurable. And also it's hard to see sometimes. Yeah, like when there's bright sky like that, it's pretty hard to see. So I have to fix all this. Yeah, so basically the first thing that popped to you is this in the middle. Sorry if I did with the console. This is the timer. So this is the timer. You have to kill the boss. It's T minus because it's T minus the bomb explode. Right, so in the middle of the map there will be a bomb hidden. Like you can't access it until like the monster is dead, the big boss is dead. So the point is really just to kill the boss anyway. And all right, and as you can see, small number here, that's my frame rate. So it's now part of the HUD, literally, so it's really cool. It's not just like floating there. Same thing on the right, this is the networking load with the bits per second and the bytes per second. So as you can see, as I move, the little bar goes up and stuff. So it just makes the HUD cool, like there's stuff happening in the HUD, but they are actually real stuff happening. So I will try to add more eventually. Like the network load, it's always nice to have. I remember when I did PV2, we had a little graph on the top right, and people were always activating it because they were competitive and they want to know how's the networking going on. So I figured let's put it directly in the HUD, and it's just always there. See, as I move, there's more packets being sent and stuff, and it's always moving. It's really cool. I might even do one for the audio, maybe on the other side or in the bottom. So it's really cool. After that, we got the health. Top left, health, the shield. Top right, I find it a little bit confusing. The design is made like that, but it's not like in cement, right? It can move. So the clip is what you currently have in your gun, and then the ammo is your stash of ammo. So you have like 300 ammo, but you only have like 20 bullets in your gun. The bottom is your energy, bottom left. So that's what you use for your jetpack. And here is the boss health. And here's, I didn't do that part yet, but the number is going to be in those little empty space you see everywhere. Going to be like the numbers, like 100 for full energy and such. And there's a little other bar here that could be available for something else. So maybe if the boss has a shield or something, well, we could put it there. So I reserved the space for it. It made the progress bar cooler. Yes, and here is the messages. So this is just a placeholder message, but basically in this case, if you don't touch the like the jetpack for like 2 minutes, like it's going to show you that message. Yeah, by the way, you can jetpack because monsters are, you need to fly around most of the time to shoot them and stuff and avoid missile and stuff. So monster, I say monster, they're robots. So the message will change to whatever. If it's more important, it's going to be a different color. As you can see, there's 3 stage color. There's the green, there's the yellow, and there's the red when it's danger. But this message is just not important, so it's just green. Also, it's hard to read, so I will have to revise that a little bit. Maybe change the color of the background. And then here we got our compass. this is really not useful actually. It's just for show. Uh, it's not like a map like in Call of Duty. Even in Call of Duty, the map. It's pretty useless to have that. But yeah, so 36 is north for 360 degrees, 18 is south for 120, 09 is east for 90 degrees. So the numbers are like runways for planes basically. It's 09 is 90 degrees, 05 here is 45 degrees because I cannot put 05.5. So yeah, anyway, that's pretty much it. But there's a compass. So I like the HUD pretty much. The only part I don't like is maybe that part. I tried to do something cool here, but it didn't work well. I think the top ones work a lot better. So eventually we'll redesign that. Maybe it will be just on the side like the top. So that's for the HUD. I will show you now the interpolation that I did. So I will start a new instance here, and I will connect. All right, and I will go in. I'm stuck here. I will go in front of him, and I will move that guy off screen so you can see. And I've timed out. You see timeout here. That's what happened when you hold the top bar for too long. I didn't fix that. Alright, so oops, I'm just going to look a little bit down there. Alright, so you can see. Also, you will notice that I'm not rendering my own character anymore, so you don't see that big green thing in the middle, which was the arrows. First thing you'll notice is everything is smoother. Alright, so you could have seen it with the rotating one around here. Yeah, that one actually doesn't look so smooth. Maybe it's my recording that does this. But basically I have interpolation, so if I jump you can see it's it's smoother if I use a jetpack. So yeah, so basically I can flag any delta float to say how you want to interpolate it. Right, so I've quit that other game, it disappeared. But yeah, so that's it for the game. Now I'm going to show you a cool tool because I'm really proud of the way the rendering is done in this game. So I want to show you. This is a tool made by Intel. Alright, so you can capture the frame. So let's go to our let's show the whole thing there. So you can capture the whole frame and analyze it after. So this is a really cool tool by Intel called Intel GPA Frame Analyzer. They used to have PICs for Windows, which you can debug DirectX, but it doesn't work in DirectX 11. The Xbox One probably works. The Xbox One always be more awesome. Well, actually, no, you don't need for Xbox because in Visual Studio directly, there's a button and you can debug frame also, and it's very awesome, the one in Visual Studio, but it only works for the apps that you do in the Metro style, right? So it's kind of manage C++. It's really horrible to use to code. I mean, sorry, all the manage C++ thing, that's kind of an headache. But the Xbox One thing, it's also based on this kind of the Metro interface. So they have their own tools for this, but for just plain DirectX 11, like I'm doing right now, you can use the Intel tool, which is really cool too. I love that graph there at the top. So this is all my draw calls I do, right? So here the big one, I'm rendering the ground here. Here I'm rendering those things. And the two pink one here are the clear frames. So they're pretty high, as you can see, compared to all the other draw calls here. So it clears the render target, and this one clears the depth buffer. Those things are pretty high, but you kind of have to do them. That's why when you have multiple render targets and you start clearing them a lot, those things are pretty heavy. well, heavy. Sorry, this is like 100 nanoseconds, so it's not heavy per se. But you know, when you start doing a lot of those things, it's pretty heavy. And then here I'm rendering the pillars first. So there's a rule in rendering, and it's probably the inverse of what you've learned, because in the past you will render back to front. You know, like Doom engine stuff, because they didn't have a depth buffer. But in the more modern rendering, you should render front to back. So I'm rendering this one first, because what's costly here is each pixels that's going to be rendered. So by rendering this one first, a lot of pixels going to get dropped by the depth buffer. And you can see here in the background, this is my biggest mesh, and it doesn't take as much time to render as the other one, because it doesn't cover the screen so much. Even it has like tons more polygons. There's like 20,000, 18,000 triangle, and this one has only like 1,400. So this one renders a lot more, but you see it has less stuff on the screen, and it uses the same shader so those ones should be the same cost, but less stuff on the screen, so a lot more optimized. And I'm even saving here because I rendered that one first, so that's a good practice. So that's why those ones, the first one, this one is always the highest. This is the immediate ground. In every game, it's going to be the highest cost, because there's a couple of blending. It's blending. It has to blend between 4 different textures. Those are the bound texture, and they're pretty usually high detail texture, because this is a ground, so it has to be high details. Yeah, so the ground will always be the most costly. So that's pretty normal here. So that's why you really have to render it last. So you render all the crap on top of it. So when we start having entities, I'm going to render them on top of them. All right, and after that, I'm rendering the sky. That's the sky dome. This is only the blue sky in the background. Simple shader. Then the clouds. The clouds are a little bit higher because there's blending on them. And then we're into the HUD, so I'm just rendering it as the little quad here is the crosshair in the middle. And you can see all the wireframe change here. I can maybe have yeah, see. So I'm rendering all the HUD there. You can see it there. So this is my HUD, and you can see it's curved. So it's curved in the shader. So the reason why it's all tessellated like this, it's because I want to be able to curve it. You know, I'm curving the vertices. That's the result after curved. All right, that's what you see on the screen. Post vertex shader processing. Another cool thing, as you'll notice, is they're all packed together. Like I'm rendering the left part here, then I'm rendering the right part and the middle part. But as you can see, the result is one single draw call. And this is a lot faster because you see the size of that draw call, like how much time it takes to render this one, 47 nanoseconds. Well, if when I was rendering all those parts individually, I would have, you know, they will take about 15 nanoseconds each. And by batching them all into one, they will all take that small amount of time, because what's costly here mostly is to transfer the data to the video card and to bind the new textures also. You know, every time I had to bind a new texture, so what I did is I've put all the UI into a single textures, and I'm just setting the UVs. So this pretty standard practice, by the way. But you know, if you use maybe a third-party engine, there's a good chance it's not doing this by default. But no, I know actually Scaleform, popular UI interface thing using Flash, kind of do those things for you. So that's cool if you're using Scaleform. But Scaleform is like, holy crap, $50,000 or whatever. So okay, so that's for the HUD. Really cool, all rendered at once, as you can see. So I'm using a sprite batch, dynamic sprite batch, to render all my UI, by the way. Then you can see all the little progress bar here. Again, it's all sprite batch. That's the horizontal one. Then the vertical ones, they use a different texture. Uh, and then I'm going to render all the text one by one. So this one I kind of had no choice because the text is not dynamic, but it's created at app launch because the text could be whatever language, right? It could be Chinese or whatnot. So as you can see, the texture bound for it. This is the texture. So the text it render the texture. So actually that texture here is twice too large, 128. I can split it in half here. So I will do that. That would be a good optimization to do. So you can see all those little annoying render call here. Well, those are all those like text, clip, ammo. You see, this one is way too big. I can drop that to 64. And then a bigger text here is the time. This one huge text. This is the message at the bottom. All right, this is bigger, very tessellated because you need to have a smooth curve on it. And then I'm rendering the little network bar at the bottom, and this is all my like the FPS there on the left and the bandwidth there. So that's all the text again. This one uses bitmap text, fixed font length. So this is a different kind of text. I use this for the console also, so it's more packed. It's a little bit faster to render too. And that's it. The last thing rendered is the the compass. So that's for that tool. It's really cool, and I don't think I have anything to show you for today. I'm going to probably start doing some guns today. That will be really cool to get. And hope you enjoyed. Thanks for watching.